Hi, I wanted to run through a couple of free response problems that I've uploaded, and I think that you should print all of them that I gave you here, work through the videos that I've created, and then try to see some commonality amongst the cluster. That's what my goal was, to kind of group them all together. And then work out the rest of them on your own. You can submit them to me once they're completed. And then once you're done with them, you can check what your answers are online. They have the scoring guidelines. So the one I will be completing in the next, in this video is from 2014. It's problem number 5. Again, all the problems from past exams, 1 and 2, you could use a calculator, and then 3, 4, 5, and 6, you can't. And so those are good practice for what you're going to be taking on the 12th, May 12th. So what I'm being given here is a table of values. They're referencing 2 different functions, f of x, g of x, along with their derivatives. However, I don't have a function equation to work from. What I have are a table of values. They give me actual values for f of x for 4 different x's, but then in between, within those intervals, what I have is whether or not the function is positive or negative. So I'm just going to run through all of these questions, and really they're independent of each other. You don't need an answer to one to answer another, but they mainly are dealing with a lot of the rules that they want you to have memorized. So let's get started. Part A is asking you to find the x coordinate of each relative minimum on the closed interval. Now, the extreme value theorem applies to any function that's continuous on a closed interval, and it guarantees extreme values. In this question, they're asking you for a relative, so not the absolute or the global min, but just a relative min. And so the kind of justification that you want to set up is that f will attain a minimum value at a critical point in the interval. And the interval is going from -2 to 3. And so your critical values are going to be when the derivative is equal to 0 or it's undefined. And since I'm looking at the value of f, the f prime row here has 2 different critical values when f prime is equal to 0. Now, that's when the other information in the table is important, because while this derivative is equal to 0 when x is equal to -1, the derivative doesn't change signs. And so it's a decreasing function, and it kind of flattens out. So that's why the slope is 0, but then it continues to drop. And so that's not a minimum value, because it's decreasing, it flattens out, and then it continues to decrease. So instead, you want to clue in on the critical value when x is equal to 1, because the derivative changes from negative to positive, and it's exactly how you want to justify why there is a minimum value, a relative minimum value of a function. So f attains a minimum value at a critical point in the interval. The 2 critical points are when x equals -1 and x equals 1, because the derivative f prime of x is equal to 0. However, to attain a min, f prime of x must change sign from negative to positive, and this occurs when x equals 1. So find the x coordinate of each relative min and then justify your answer. So my justification is that minimum values are critical points. There are 2 different critical points, and only one of the critical points is going to have a min, and that's because the derivative changes signs from positive to negative. When I read point B, question B, sorry, it says explain why there must be some value C. C is an X, right? And you know it's an X because it says that C is inside the parentheses here. So explain why you must have a value C within the interval from -1 to 1. So in the table, basically, they're only talking about this section of the table. And then they are talking about the second derivative, which is not in the table. And so this, if you remember from class, that those theorems, the extreme value, the intermediate value, and the mean value theorem are referred to as existence. So whenever you are being asked to justify, explain why this has to be, explain why this has to exist, it's kind of a clue in the problem that they're asking for one of these three theorems. So the intermediate and the extreme value theorem are guaranteeing something about the function itself, where the mean value theorem is the one that is talking about what has to be true about the derivative. And so that's a clue point here, is they're asking me about the derivative of the first derivative. They're asking me for the second derivative. And so the mean value theorem guarantees that the derivative must attain the average value of the function, and the average value of the function must equal the derivative at some point. So what I'm trying to find is when is the slope equal to 0, and they give you a clue because these two endpoints are, you know, like I had mentioned, just one section of the table. So basically, if they're asking you to justify, it's nice to throw in which theorem you're using. So by the mean value theorem, and if you have the time, write it out, but MVT is totally appropriate to abbreviate. By the mean value theorem, there must be a value C for, and I'm just copying directly off of the wording of the problem, for -1 C1, such that the derivative, which I'm going to use double prime, the derivative at C has to equal f prime of 1 minus f prime of -1. So this is using the first derivative's actual values, kind of setting up like the slope formula. This is like f of b minus f of a, but I am doing f prime. And so the derivative of f prime is f double prime. So this is saying that the derivative of this function must equal the average value on the interval from -1 to 1. And so this is my b minus a here. Now in the table, what I'm looking for is f prime of 1 and f prime of -1. And both of those values are equal to 0. So if I were to continue to simplify, my fraction would be 0 minus 0 over 2, or just 0 over 2. And this is equal to 0. So the mean value theorem guarantees this, and I think that that was probably Khan Academy last week that was due. The mean value theorem came up a lot. And so go back and practice the mean value theorem, what it says, what are the conditions. And notice they didn't ask you to find the value of C for which this occurs. You can't, you don't have an equation to solve for C, but what you know is that there must be some C for which this is true. So this right here is, like I said, the slope formula, f of b minus f of a all over b minus a, using these x values and then the output values from the table. Let me read it through to make sure I answer the question. But the mean value theorem, there must be a value C such that the derivative, good. So I think that is fine. That explains why there must be a C by the mean value theorem. Next question, part C. The function h is defined by, and so what you see is the chain rule is about to happen here, because you've got a function inside of a function, and they want you to find the derivative of this. So this is, remember that the derivative of a function inside of a function, here's your chain rule, is going to be the derivative of f with respect to g of x. So the inner function doesn't change when you take the first derivative or the derivative of the outer. and then you multiply times the derivative of the inner. So there are two different derivatives, but at different input values. So when I consider what is defined as the h function here, it says that h is defined as ln of f of x, and they want me to find h prime of 3. So that's going to be h prime of x is going to be the derivative of ln, which is 1 over x, evaluated at f of x. So instead of just putting 1 over x, I'm going to put 1 over what is inside the parentheses. And then I have to multiply times the derivative of the inner function. The inner function is f. And so this right here is like f prime of g of x, right? It's the derivative of ln of x, but evaluated at f of x. And now that's when I can give myself a value for the input value is 3. And so I need a couple of pieces of information from the table. I need to know what f of 3 is, and I also need to know what f prime of 3 is. So f of 3 is at the end of the table here. F of 3 is 7, and f prime of 3 is 1/2. So f of 3 is 7, so it's going to end up being 1 over 7, and then f prime of 3 is 1/2. And so when I multiply those two together, the derivative of h at 3 is 1 over 14. All right, finally, what you have being asked of you in the last part of the question is once again the chain rule. So what I just wrote up there was the chain rule for derivatives. Now this is the integral of the chain rule. And so remember again that an integral, this is what you were doing this week on that was due today in Khan Academy, was that the integral is the antiderivative, and it's saying, can you give me a function for which this is the derivative of the function that you're writing as the antiderivative? So basically for part D, when they ask you what is the integral from -2 to 3 of this function, this function here is the derivative of f of g of x. So if somebody asked you for the derivative of that, it's the derivative of the outer function with respect to the inner times the derivative of the inner. And so I still need to use the bounds here, right? This is my b and my a. And so now what I'm being asked to do is take f of g of 3 and subtract f of g of -2. So I'm going to need a few things from my table, g of 3 and g of -2. G of 3 is 1, and then g of -2 is -1. So f of 1, g of 3 is 1. And then g of -2 is -1. Hopefully you have this in front of you, as I'm doing it. Then I need to look at the x function, the f function evaluated at 1 and -1, and that would be 2 and 8. So this is going to be 2 subtract 8. And so my final answer for this part of the question is going to be -6. Again, what I want to remind you of is where you can check what the scoring guidelines are. And so for this question, what you would have received is 1 point for saying that x equals 1 is a critical point and the derivative changes sign from negative to positive. The next question, using the mean value theorem, you would get a point for stating that you're using the mean value theorem, and then another point for showing that you found f prime of 1 and f prime of -1, and that equals 0. So that you found the average rate using f prime from the table, and that tells you something about f double prime. Question C, you get 2 points for being able to write out the derivative of h. And so that's the 1 over x, the derivative of ln, and then multiplying times the derivative of the inner function. And then finally, the fundamental theorem of calculus says that an integral, another way to think of it, is the antiderivative. And the antiderivative of a definite integral from going from a to b is capital F of b minus capital F of a. So that's what they mean by the fundamental theorem of calculus. And then finally, 1 point for the final answer of -6. Again, I hope this helped. I'm going to do one more video. I hope you're watching them. I'm not getting a lot of views. Do what you need to. But this is what I suggest. Hopefully you followed along. I'll make another video and you could do 3 on your own. Submit them to me. You'll earn yourself some points in your grade. Bye, and I'll see you again.